2001 AP Chemistry Free Response, Question 6. The iodide ion reacts with peroxidisulfate ion, S2O8 2, according to the equation above, assuming that the reaction goes to completion. 6a. Identify the type of reaction, combustion, disproportionation, neutralization, oxidation reduction, precipitation, etc., represented by the equation above. Also give the formula of another substance that could convert I negative to I3 negative. This equation has to be an oxidation reduction, with Cr2O7 being another substance that could convert the I negative to the I3 negative. 6b. In an experiment, equal volumes of 0.0120 molar I negative and 0.0040 molar S2O8 2 are mixed at 25 degrees Celsius. The concentration of I3 negative over the following 80 minutes is shown in the graph below. Bi. Indicate the time at which the reaction first reaches completion by marking an X on the curve above at the point that corresponds to this time. Explain your reasoning. To find the time at which the reaction first reaches completion, you would figure out by where the slope starts to become constant. So right where, about here, where the slope starts to level out, is where the reaction reaches completion, because there is no more moles being made, which would approximately be about 35 minutes. Explain how to determine the instantaneous rate of formation of I3 negative at exactly 20 minutes. Draw on the graph above as part of your explanation. To find the instantaneous rate of formation at 20 minutes, you would have to create a slope right at 20 minutes on the graph, and you would use this slope to find the rate. C. Describe how to change the conditions of the experiment in Part B to determine the order of the reaction with respect to I negative and with respect to S2O8 2. Additional experiments, each with the same concentrations of S2O8 2, can be performed with adding different concentrations of I3 negative to find the rate constant for I3 negative. 6d. State clearly how to use the information from the results of the experiments in Part C to determine the value of the rate constant K for the reaction. And this would be the rate expression, including the I negative to the X and the S2O8 2 to the Y. (6e) On the graph below, which shows the result of the initial experiment as a dashed curve, draw on a curve for the results you would predict of the initial experiment were to be carried out at 35 degrees rather than 25 degrees Celsius. At 35 degrees Celsius, which is a higher temperature than the original, the reaction will take place faster and level out at a faster time, around about 18 minutes instead of 20, but still level out and make the same amount of moles.